Hello everyone, this is Fahad Mirza and I welcome you to my channel. Radiology reports are one of the crucial components of medical diagnosis, providing a detailed description of observations from radiological images. But the growing demand for radiologists to interpret an increasing number of images has created a shortage, and we are all aware of it. If you have ever been to a radiologist office, you know the wait time. To address this challenge, researchers have been exploring the use of AI tools to generate radiology reports automatically. And I believe that is one of the most promising area when it comes to generative AI, and I mean the broader medical field. That is why this research paper, which is called as LaB-RAG, really sounds very promising. Radiology reports or radiology report generation, which is also called as RRG, is a specialized form of image captioning that involves generating text descriptions of radiological images. Recent advances in large language models or LLMs have shown real promising results in generating coherent and accurate text. But the application of LLMs to RRG requires domain adaptation to effectively capture medical concepts and terminologies. Now, this paper not only tries to deal with that, but it goes few steps ahead. Current approaches to RRG typically involve the fine tuning of vision language models on medical image datasets, but this approach can be computationally expensive and requires significant resources. Also, the use of high dimensional latent or token embeddings to represent image features can be real limiting factor here. And LaB-RAG tries to resolve that. It is a new framework for RRG that uses label boosted retrieval augmented generation. If you don't know what retrieval augmented generation is, in very simple words, RAG or retrieval augmented generation is a process where you take your own data, such as these radiological documents or images, then you convert that data into numerical representation or embeddings with the help of an embedding model after chunking it or slicing it into smaller pieces, and then these numerical representations or vectors are stored into a vector store. Whenever a radiologist or anyone asks a questions about the patient, about its radiological data, then that question is converted into numerical representation, and then a similar search is or similarity search is made in that vector store for the similar radiological data, and then that returned similar data is augmented with that prompt and given to LLM, and that is how LLM has more grounded response as per the patient's own data. That is the whole idea behind it. Now, this LaB-RAG uses classical machine learning models to derive categorical labels from images, which are then used to inform retrieval augmented generation and provide textual image descriptor to LLMs. This approach has several key advantages. First and foremost, LaB-RAG does not require training any deep learning models, which is really cool, making it a more efficient and computationally friendly approach. Secondly, this method can achieve state of the art performance for RRG, outperforming other models in the literature. And finally, LaB-RAG provides a generalizable framework for using classical machine learning to boost LLM performance without and with potential applications beyond RRG. In this paper, they have presented the details of LaB-RAG and evaluated its performance on a benchmark RRG dataset. They also have provisioned a critique of a commonly used RRG metric, demonstrating that it is possible to artificially inflate its results without true data leakage. These results highlight the potential of LaB-RAG as an efficient and effective approach to RRG and demonstrate the importance of critically evaluating evaluation matrices in AI research. So really good paper. I really like the way they have written, but all is not all is not well. The problem is that when you try to see the code of it, you try to implement it. For instance, I went to their paper, which is this. You click on PDF, you go here, you go at the top where the abstract is, and I'll take you there. And once you click on this GitHub link so that you could implement it, you are met with this 404 not found. So I think The paper was released, I believe, let me check when it was released, let me go back, on 25th of November. Still very, very early, like 4 or 5 days ago. But I believe when you release a paper to archive, you should also make sure that code is there if the code link is there, or otherwise just mention it on the paper that code is not yet available. Anyway, regardless of that, still I believe a real good project. And if not this, maybe someone else can create a tooling around it where we can see some real implementation of this stuff. So that's it. I hope that you liked it. If you did, please consider subscribing to the channel. If you're already subscribed, please do me a favor and share it among your network, as it helps a lot. Thank you for watching.